Hello, I'm Sean, and in this video I'll be telling you about the chemistry of karst, or the dissolution of carbonate rocks to form karst topography. This video seeks to answer three main questions, those being what is karst topography, how does it form, and why is it important? The term karst describes a distinctive type of terrain and indicates the dissolution of the underlying soluble rock by surface of groundwater. These areas are usually found in regions of plentiful rainfall where the bedrock consists of carbonate-rich rocks such as limestone, gypsum, or dolomite. These rocks are easily dissolved by slightly acidic rainwater. These landscapes are characterized by vast systems of underground caves, water reservoirs, sinkholes, rock fissures, underground streams, and other cave formations like the speleothem you can see in this picture. Overall, karst landscapes cover about 10% of the world's land surface, and these subterranean karstic systems provide approximately 20 to 25% of the world's supply of drinking water, making them incredibly important to our overall survival. So how exactly does this happen? How are these carbonate rocks dissolved? Well, in addition to physical weathering such as the movement of water or root wedging, carbonic acid plays a huge role in the dissolution of these carbonate-rich rocks. Carbonic acid forms in the atmosphere when small amounts of CO2 reacts with water, forming an aqueous solution of carbonic acid, or H2CO3. This is a reversible process, and the H2CO3 can dissociate into hydronium ions and bicarbonate ions. This makes rainwater slightly acidic. This slightly acidic rainwater has other implications environmentally, some of which have been exacerbated by humans. So the more CO2 in the atmosphere, the more carbonic acid is formed and enters the ocean, making the pH of the ocean more acidic. This can cause coral bleaching and other ecosystem damage. As well, CO2 or other gases can form highly acidic rain or acid rain, and acid rain can completely wipe out an ecosystem. So as the rainwater falls to the ground and makes contact with these carbonate-rich rocks, or rocks rich in CO3, this reacts with carbonic acid and dissociates the calcium ions and bicarbonate ions, making a solution of calcium and bicarbonate. This solution runs along fissures in rocks, and over periods of thousands to millions of years, these fissures can grow into big cave networks or aquifers. This is also a reversible process, so the calcium can precipitate or solidify into calcium carbonate. So to summarize, carbon dioxide and water in the atmosphere reacts to make carbonic acid. This carbonic acid reacts with calcite or calcium carbonate and forms a solution of calcium and bicarbonate ions, which runs away from the rock, leaving gaps over periods of thousands to millions of years. The precipitation of this calcium solution can form these really amazing speleothem. These pictures I took in Carlsbad Caverns in New Mexico. I think the one on the right was about 20 to 25 feet tall, so these formed over long periods of times, thousands to millions of years. If you ever get the chance to visit, I highly recommend. The picture on the left is the walk down. You get to feel the cool air coming up. It's a really great experience. So here in Central Texas, we get our water from the Edwards Aquifer, which is a karst formation. It supplies drinking water for about 2 million people. The Edwards Aquifer water is filtered by the layers of topsoil, and although it can't filter out all the contaminants. The water table is so high in some places that whatever contaminants enter would go directly into the aquifer, and the aquifer cannot easily be decontaminated. So our aquifer is extremely susceptible to pollution, and this can be mitigated by better development practice and public education. So you can see on this map, UTSA lies in a transition or artesian zone. Artesian zones being areas where the hydraulic pressure of the water is great enough to send the water out of the ground, making springs like the ones you might be familiar with in New Braunfels or San Marcos. These springs provide habitat for about 40 endemic species in this really clear, cool water that comes up out of the aquifer, like the Texas blind salamander, which with its external gills is able to capture the oxygen that is concentrated in this cold water. So cold water holds more oxygen. So this organism relies on the constant flow of cold water in order to respirate. Another one of these endemic species is one of my personal favorites. It can be found at depths of over 600 meters deep. It has only been found in 3 wells around the San Antonio area, and it makes up its own genus, Satan aristimus, or the wide-mouthed blind cat. There are many other species that I recommend checking out. It's very interesting, and the protection of it is incredibly important. So thank you for listening, and here is my works cited and my image credits.